Hi folks, today I bring to you two LCD drivers from the manufacturer Sanyo used in the car radio panel. This combination of the drivers has been focused in previous videos, so I suggest viewing other videos as a complement to this technique. One has the reference Lc75853, allowed control of a total of 126 segments and 30 keys. And I have also 4 pins for general use. Lc75833 is available in the 105 keys or 93 segments version. This is present in the market with the two kinds of the values to control the segments. Allow the general purpose 8 pins control. Unlike the Lc75853, it does not have the data output pin, as it does not have pins that dedicate to the key functions. Therefore, it does not allow the use of the keyboards for interaction with the panel or with IC. All the information is present in datasheet that can be easily found in the net. Also, some appear in the Chinese and have wrong information. But just look at the ones that have the Sanyo symbols, and you find all the graphics is necessary to put the ICs working. The address from the Lc75853 are the 42 hexadecimal for the control and the writing, while the 43 hexadecimal allow to read the keyboard. In the Lc75833, the address is only one, the 46 hexadecimal for control and writing the information to the driver. The panel model used belongs to the Kenwood 35 star 4 and KRC score 758R. This is a reference or the model of the car radio from the Kenwood, but these drivers come in main models and brands. By this reason, you can find these ICs in the other brands of the car radios. I have already made other videos where pairs of combined drivers are used in order to increase the number of the segments. The principle is simple, and it involves having both drivers listening to the data input pin and all make the reaction when the address of the recipient match yours. I didn't build a library for the drivers. I didn't make sense to expend time to do it. I used the direct control by message that I left in binary format, so that can change and thus directly observe the impact on the display. As usual in this type of drivers, you only need 3 control pins, 4 if you're using the data output. They are the data input, the clock, the chip enable, and lastly the data output to the case of the Lc75853. The operating voltage of the Lc75853 is between 4.5 and 6 volts, whereas the Lc75833 work between 2.7 and 6 volts. Both data refer to the most severe temperature range. This information is present in datasheet. This is the 4 signals present in the pins to control these 2 drivers. The first line, the yellow, belongs to the data input, and you can see the different data passed through this line. After the light blue is the clock, the violet is the third line and belongs to the chip enable, and the last, the dark blue, belongs to the data output. Okay. I make one alert to pay attention to the information related with the stop of the clock. Okay, if the stop the clock happen in the high value or low value, you need change the action. Okay, this information is present in the data sheet and is also to the auto output. Okay, is necessary pay attention to the stop of the clock. This is the identification of the segments values. Note from this side, from this line, belongs to the 75833, and this side belongs to 75853. Okay. The number of the elements or the segments belongs to the wheels, and the small predefined shards present here with the number. I don't worry about the collect this information to the perfect way, okay, but is only one information because I used a code to run segment by segment and only I note the number, okay. I'm running the code over the Arduino Mega. In this case I have the pin 7 is the data input, 8 is the clock, 9 is chip enable, and the last is the data output. Okay, I only use 4 pins to control all the data belongs to these drivers. This is the power. In this case is the plus and the negative. The bulbs in the retro illumination of the display get 240 milliamperes. Okay, here you can find the number of the values corresponding to the keys. Okay, 32 for example, 25, 24, 23. This is the numbers or is the bit you receive when you process the reading the output from the driver 853. Okay.